Alright, section 3. Rail identification sections. The rail section that we test come from the different steel mills and are various types of weights. It's important that we know how different and identify the information performing on the job. The rail section are manufactured today are identified by two markings that are located on the web of each rail. These markings are rolled into the rail during the final stages of rolling mentioned above. The first marking referred to below is called the brand. The rail section brand is raised lettering on one side. The information provides you with the section type or style. The second marking is referred to as the heat stamp of the rail section and is located opposite side of the web as the brand. The information used to identify the specific rail section. All right, the rail brand is the rail web is branded at least every 16 feet. The branded will consist of the following information: weight per every 3 feet of rail, 2 or 3 digit number, section 2 letter code, 2 process, hydrogen elimination 2 letter code, manufacturer, spelled out letter code or symbol, year round 4 digit number. Year rolled 4 digit number, monthly rolled lines in Roman numerals. So first you have the example is the rail weight for 3 feet, and then you have the 2-letter code, and then the type, the manufacturer, process with hydrogen elimination, the year, and the month rolled in Roman numerals. Rail stamping. The web of each rail is a hot stamp. At least every 16 feet on the opposite end of the branding should not be within 2 feet of the proximity of the rail end. The data will contain the following information: the heat number, the rail position letter, the ignite strand and bloom number, the method of hydrogen elimination optional. Note, ingots are numbered by the letters that succeed each of the others starting with A, designating the position in the casting. Stranded bloom members may be joined and separately coded manufacturer preferences. Continuous cast stamps example. First shows the heat number, the type of the rail position letter, the rail bloom, and the strand, the method of hydrogen elimination. In the ingot stamping, you have the type of rail, the heat number, the rail type of the rail, the heat number, and the rail and letter in ingot stamping. Steel processing hydrogen elimination. Steel making process will identify the method of hydrogen was removed from the rail steel within molten state and ingoted bloom strand or rail section form. This most commonly method of North American steel is controlled cooling. This method is used and identified by the following: CC for controlled cool, BC bloom cooled, VT vacuum treated, HH head hardened, OH open hearth method. Gases absorb the liquid steel during the heat of the process can cause shatter, cracks, and voids, inclusions of harmful ammonia into the steel after it is solidified, and hydrogen has been recognized for some time to be a predominant cause of shatter, cracks, and other inclusions during the manufacturing process. By using the cooling process above, rail manufacturers have had significant success in removing hydrogen from the rail. Alright, the rail sections encountered in North America. The rail section identified an engineering association established for the design specifications of the section. The most commonly used section used in North America is the RE section, a North American Railway section. RE stands for American Railway Engineering Association, or AREMA, American Railway Engineering Maintenance of the Way Association. Followed by these abbreviations, you have the AAR, American Railway Association High Speed A, and Low Speed B. AS stands for ASCE, the American Association of Civil Engineers, and as follows. Also ASE, it stands for American Association of Civilian Engineer. AB stands for Askins Bowman, CB stands for CNO or BNO, and DY stands for Dudley. DMY stands for Dudley Modified, NYC stands for New York Central, PS stands for Pennsylvania Railroad Standard, NH New York, New Haven, and Hartford, and HF Head Free. The railroad grade stamp. The railroad grade stamp is a series of numbers that designate the grade of the strength of the rail. The standard rails should be either CC control cool, MH medium hardness, CH control cool end hardened, 3HB or 300 Brindle hardness, CRMO or chromium molybdenum alloy, or chromo rail or chromium molybdenum alloy, same thing. SS standard strength, IH intermediate hardness, HISI high silicon silicon, SMH, intermediate hardness, SA, special application. Premium rails, HH, head hardened, FHH, fully head hardened, FT, fully heated treated, CT, controlled treated, LHH, low alloy head hardened, LHH, low alloy head hardened, DS, micro alloy head hardened, and HCP, high carbon perlite, NH, new head hardened, OCP, 1% carbon perlite, HS, high carbon micro alloy head hardened, and DH, deep hardened head hardened. It continues DH37, DH37S, and DH370, deep hardened 370 brinal, DH40, deep headed 400 brinal, HE, hyper utasoid, and HE 370, hyper utasoid 370 brinal, HE 400, hyper utasoidal brinal 400. Rail manufacturing process. The manufacturing process of steel requires huge quantities of raw materials. Many processes, steel is essentially a combination of iron and carbon. The products, along with the other alloys, determine the metallurgic characteristics of the furnished steel. And for example, the manufacture of 1 ton of steel, it can take 1.5 tons of ore, and 2/3 of a ton of coal, and a quarter of limestone. 1.5 ton of iron and steel scrap, or steel scrap. 165 tons of water, 8 tons of air. Other alloys are added with the metallurgic structural steel. Rail manufacture can be grouped into 4 stages. There are 1, the production of molten steel, necessary raw materials. 2, casting the liquid from the ingots, continuously cast blooms. 3, the rolling process of the cross-section of the rail. 4, the finishing, which consists of cooling, straightening, cutting in the desired length, and final inspection. Current steel rail is produced by the basic oxygen process, electric and furnace processes. In effect, the heated procedures by gas and electricity. Both of these processes produce a molten steel material high quality that is ready to be rolled into rails. While in liquid, they are poured into molten ingots. After an ingot has been cooled, solidified, they are stripped from the molds and sent into soaking pit. In the soaking pit, they are reheated to a rolling temperature of approximately 2350 degrees Fahrenheit. Once the temperature is reached, they are moved to the rolling blooming mill where they are rolled into the final form. This usually reaches the temperature at about 1900 degrees Fahrenheit during completion process. When rolling is complete, each rail is moved to the cooling bed and cooled about to 1,000 degrees Fahrenheit. The purpose of controlling the cool is reduced to the hydrogen content, improve the hardness of the rail. After the rails are removed from the control cooling bed, they are passed through a roller straightened vertically and laterally. Once the rail is straightened, it must be inspected processed prior to shipment. Section 4, development of defects.